Have you ever pondered why creatures, including humans, often cooperate even when it seems against their immediate interest? Could it be that the laws of evolution favor the survival of the most cooperative rather than the fittest? Today, we delve into a fascinating concept that challenges the survival of the fittest narrative: the iterated prisoner's dilemma and how it relates to evolution. The iterated prisoner's dilemma is a standard example of a game that shows how two individuals might not cooperate, even if it appears that it is in their best interests to do so. Picture two criminals arrested and held in separate cells. They can either stay silent or betray the other. If one betrays and the other stays silent, the betrayer walks free while the other gets a heavy sentence. If both stay silent, they get a light sentence. If both betray, they both get a moderate sentence. The dilemma is, do they trust each other to cooperate and stay silent, or do they betray each other to avoid the worst-case scenario? Now, imagine this scenario repeating over and over again. This is the iterated prisoner's dilemma, and it has a surprising relevance to evolution. In evolution, organisms often face similar dilemmas: to cooperate or not to cooperate. For instance, a group of meerkats take turns to stand guard while others forage for food. The guard meerkat risks its life but ensures the survival of its group. This is cooperation. But what if a meerkat chooses never to guard but always to eat? Here's where computer simulations of the iterated prisoner's dilemma come into play. They show that always defecting, like the meerkat that never guards, isn't the most beneficial strategy in the long run. Instead, strategies that involve cooperation, like tit for tat, where an organism reciprocates the action of the other organism in the previous interaction, tend to fare better. These simulations suggest that organisms that cooperate can have a survival advantage over those that always act selfishly. This brings us back to the pioneering work of Peter Kropotkin, a Russian scientist who argued that cooperation, or mutual aid, is a significant factor in the evolution of species. Kropotkin observed that in many species, cooperation is a common survival strategy. His ideas were often overshadowed by the more popular survival of the fittest theory. But these recent findings from the iterated prisoner's dilemma simulations provide robust support for Kropotkin's theory. In summary, the iterated prisoner's dilemma, a concept from game theory, provides a fresh perspective on evolution. It demonstrates that cooperation, not just competition, plays a crucial role in the survival and evolution of species. It underscores the fact that survival of the fittest might not always mean survival of the strongest or the most selfish. These findings have profound implications. They compel us to rethink our understanding of evolution and survival strategies. They highlight the importance of cooperation in not just the animal kingdom, but also in human societies. After all, we too are a product of evolution. It's a reminder that in a world that often seems driven by competition and conflict, cooperation might just be our best strategy for survival. So the next time you find yourself in a dilemma, remember the iterated prisoner's dilemma and consider the power of cooperation. Because evolution might just favor the most cooperative, not just the fittest.